This lecture is going to talk about how to work with reading and writing files. And really what this will give us is the ability to persist some of our data in between when we're running our applications and when we close them down. Really what we've been limited to at this point is that when we start up our application, any input, any interaction that we want to have for our code has to come from the command line, has to come from user interactivity. This way it gives us the ability to sort of read in some data files and possibly, depending on what the user input would be or the result of that, create a resulting output file as well. So in order to access some of the file input-output stuff, we have to add a directive to the top, and the library that we want to bring in is fstream. And fstream stands for file stream, just like input-output that we get for being able to do cin and cout comes from iostream. And remember, a lot of the data features in C++, they work with things that we refer to as streams. And really what that is it's really just the data that we're working with. On top of that, I want to be able to also work with some strings. So I'm also going to bring in our string library as well. Okay, so what's neat about how C++ handles input and output with files is it's very similar to how it handles input and output to and from the console. We use our ostream operators like this to do output, and we use these to do input, and it works very similar to that with the file. But first what we have to do is actually get a file, or at least a handle that says this is where we want to write a file if it doesn't already exist. And to do so, we're going to create a variable of type ofstream, and I'm going to call this write file. And so what we're going to be doing is we're going to be writing to a file that it will create in our file system. But right now, really, all this is it's just a declaration of the variable. It's not doing anything yet. What we actually have to do is we have to tell it what file that we want to open. And often when we talk about writing to a file, usually it's just, well, yeah, you just write to it and there it is. But we actually have to open the stream in order for C++ to be able to write to it. So we do that by calling the .open method on it, and we're going to call this example.txt. Now the txt part is not important, it's not necessary, but we're doing .txt so that Windows knows how to open it, and all I have to do is double click. It could just as well be this, it could just be just as well this as well. It doesn't really matter. We would say that that's arbitrary. The data itself that's being written to this file is going to be the same regardless. Okay, so now what we have is we declared our ofstream, we've opened our file now, and now we want to write something to it. And before we go any further, what I will usually do, so that I don't forget before I even start working with the file, is I'm going to go write file.close. And we have to do this for a number of reasons, and it varies from operating system. But really what you want to do is you want to be able to open the file, but then you don't want to forget to close it. Because depending on how your application runs, it may leave a hanging process on there, and you can no longer work with that file then. So we want to be able to make sure that we have a pair of opening the file and then also of closing the file as well. Okay, but on to writing to it. So we take our object here, and now we use these output operators. It's very similar to how we would do a cout, but in this case, instead of outputting to the console, we're going to be outputting to the file. And we're going to go with the old hello world example. And this should be enough to write to our file. So Let's run it and see what happens. Alright, it's waiting on my get character, and there we go. And it doesn't really look like anything happened, but again, remember, we are writing out to the file. So to get there, I'm going to right click on my project, and I'm going to say open folder in Windows Explorer. And then open in my other window, and here we are. And you'll see in the base directory of our project, I now have that example text. And to open that, sure enough, it wrote hello world. Let's do something additional on top of that. Let's say in the next line, write file. Let's just say writing to a text file. And run it again, because we can do multiple outputs. Okay, I'm going to open back up that directory. And we see it says hello world, and it says writing to a text file. So what we would do if this was our console is we would add in an end line to that. But that doesn't necessarily mean the same thing when writing to a file. What we do want to write to our file now instead is doing a new line character here. And that will create a new line in our text file. Have that process, and there we go, and it brings it down to the next line on that. So you want to be able to remember to do your new line character on that. These two lines could be combined if we had to, and this would mean the same thing. Okay, so let's review what we have here. Created an OFStream object, opened the file. Doing this with our output operator, we're saying write hello world new line. The next line says writing to a text file a new line, and then finally close. And if you're doing this, in likelihood you could output this, you could comment this line out so that when you run the program you get a little blip, but then you can go and you can open your file to see if it actually wrote as you expected it to. And again, right click on your project, open folder in Windows Explorer will take you to that text file. Okay, so this is writing out to a file. It's very simple. In fact, in some ways it's probably a little more straightforward than how we would do it in .NET. Just a couple of lines and there you have it. So that's writing to a file. But the other part is, well, how do we read from a file? And it turns out it's very similar to that. Instead of an OF stream, we're going to declare an IF stream. OF stream would be output file stream. IF stream would be input file stream. I'm going to call this one read file. And this declaration is a little different in that we can actually declare the file that we want to read right off the bat. And the reason is that we want to be able to have this initialized right away, because there's not much we're going to do with an input stream if it isn't that we're going to read it. That being said, the first thing we have to do is that we have to acknowledge that maybe something went wrong. Maybe the file didn't exist. Maybe we don't have permission to actually access that file. So before we do access that file, we have to test to make sure that it indeed was able to be opened correctly. And so there is a method on here called isOpen that we can call. And if it is open, it will return true. If not, we can output an error message to say there was a problem with opening the file. And I think what's interesting to note here is that you'll see that we can actually mix the output that we're working with. We have output that's going out to a file, but then on this line we have an output that's going out to the console itself. So you're not limited to just one of them. These things can live side by side. Okay, so here on this line we're testing to see if the file is open. And what we have to do next is, well, we have to say, well, how do we want to read this file? And really, usually what you're going to work with is you're going to want to read that file line by line. And that sort of implies that what we have to do is loop through the file in order to be able to say, okay, this is what is on the first line, this is what's on the second line. And so what we're going to use for that is a while loop. And we use a while loop because we don't really know at this point how long the file is. And it really doesn't matter. All we know is we just want to keep reading it until that file is done. So we're going to say read file, and then again we're going to tap into a method on there called good. And what good does is it tells us, is the next line good? If it's not, that means that the file is done. The file is, we've reached the end of it. Okay, so a lot of things to test. First, test to see if it's open. Next, test to see if the next line is good. Once we're in here, we get to use something called getLine, which is very similar to what we can do on cin as well. But in this scenario, what we want to do is we're going to pass it our IF stream. So we're going to say read file, and then what it expects is a string in order to be able to read it. And that's something that we don't have defined. So we're going to actually say here string, and let's call this line content. And this is something that the read file will read in to that variable. And so we're going to say line content. And then while we have that, now that we've read it in there, let's actually also output it to the screen so that we can see, well, okay, is it being read properly? Is it doing what we expected it to do? And there we go. And actually, I kind of violated my own practice here in that what I want to do is I want to have a matching close, if you recall. And now our immediate thought is to put this after the if-else statement, right? Because I'm opening it here, I'm doing some work on it, and then I'm closing it. But we also have to say that this is checking to see if it's open. If it's not open, we're going to get into this if block, and it wouldn't make sense to close it because something went wrong and it never opened to begin with. So actually we're going to put it right in here after our while loop, and we're going to say read file dot close. And we should have done this right away. Every time you work with opening a file, you should have an automatic closing as well. Okay, so what this is really doing is we are starting out by writing to a file, and then we're going to open the same file and see if the contents match what we'd expect it to be. I'm going to throw my getChar back in there so that we can see what's going on the screen, and let's run it. And it is matching up with what we'd expect it to see. And to make sure we're not cheating anything here, let's actually comment out this whole write file piece so you can see the strings are in fact independent. And let's just read off of what we know that that existing file is. Alright, and that's what it said. Hello world, writing to a text file. And let's go back in and let's change it. And I'm writing this in through Notepad. Close that down, fire it up again, and you'll see that it's doing exactly what we set it to do. It's reading each line. We're doing a cout, output the content, do an endline character, and here we are. And so up to this point, you know, this is great that we can read a file and we can write to a file, but we're not really doing anything with it. And this is going to come into play a little later. Right now it's more of just another trick that we have lined up to be able to persist some data out, but there's some other considerations that we want to take into discussion about, okay, well, how should we format that data? And that's a big part of it. Right off the bat, though, what we can use, which would be neat, is we can use this portion, and you could use this for logging right away. So maybe, you know, you want to be able to keep appending text to the end of a file or something like that. This would be very useful in terms of being able to log a file out. And sometimes what you'll have is you'll have applications that they'll run faster than it makes sense to debug. So maybe it's some sensor data off of a piece of machinery, maybe it's a graphical program. Going through and stepping through the code in those scenarios just doesn't work because you're getting real-time data. And so trying to step through and figure out what's going on isn't always helpful. But you can write out to a log file, and then instead of trying to step through the process, you can open up the log file and see what's going on. And you'd have a timestamp on it and maybe an error or some data that reads out. So this is very useful. It's also very common use of this kind of thing. The flip side of it is also, in terms of reading a file, you may have some configuration data. So, for example, we've been working with data structures recently, and instead of having the user or perhaps have it hard-coded into the program, that initial structure data, you may have that in a text file, and you read that in instead. And it's a lot easier to change the data inside of a file than it is to go into your code and then, you know, work with the syntax of declaring an array or two-dimensional array and have to worry about semicolons and everything else than it is to just go into the file. And not only is it easier, but then you don't have to recompile your program every time the data changes as well. So again, these are some tricks that we have that we're going to be using later on, but at this point right now, it's just kind of a standalone OF stream, write to a file, IF stream, read to a file as well. I will put this code out in GitHub in a 1031 folder, and we will continue to talk about this next week.